All right, hi, this is Tim Bibbins. Today we're going to pick up on chapter 3, and it's called Getting into the Details of Variables. Um, if you remember last time, chapter 2 was kind of an overview of programming. It kind of gave you a little bit of what variables were, what methods were, but now we're going to get into the details of variables and what they really are, right? So let's, in order to get through this chapter, let's create a project in Unity so that we can just work along with it, right? My assignment this week is going to be different than what's in the book. The book doesn't really give you anything that assignment like, right? So I'm going to create a separate assignment that will kind of let you practice using variables. I will create a separate video for that purpose, right? So for now, let's create a Unity project. So I'm going to go to the Unity Hub here, and I'm going to say New, and wait for that to pop up. All right. It can be 2D because we're not doing anything fancy. Last name underscore first initial. Let's call this variables lesson, right? And I'm going to put that in my 113 folder, which is in spring 21. 113, and this is going to be week 5, isn't it? Yes, I think. Actually, we're working in week 4, right? Because we're behind someone. All right, so week 4, and we'll call this week 4 variable lesson. Right? We'll select that folder. And then we'll create. And I'll just pause it while that. All right, so we have a blank, empty Unity project here, and that's good. We use that as we work through this chapter. All right, so getting into the details of variables, right? This page just talks about the difficulty beginners have in starting in coding, right? Because the words you use, they seem like English words. They are English words, but they're used in a different way, right? The rules of writing that are called syntax, right? The syntax of the code, right? So learning how to write code is learning the proper syntax, right? So we're going to learn how to correctly create variables now. All right. So in this chapter, we're going to learn how to write C# statements properly, using C# syntax to write variable statements, the game object components properties, using public variables for the Unity inspector panel, naming a variable properly, and declaring a variable for the type of data it will store. All right, so writing C# statements properly. When you do normal writing, it's in the form of a sentence with a period used to end the sentence, right? So what we need to do here is learn how to write a statement in C# that's correct, right? In C#, we end our statements with a semicolon. And if you don't use the semicolon, you will get this error right here, right? Semicolon expected. As soon as you see that, you should go in your code and find out where the semicolon is missing, right? All right. The code for a C# statement does not have to be on a single line as shown in the following example. All right. So we're going to go to Unity, right? And we're going to go ahead and we're going to create a file, a C# file. Let's create a folder for our scripts, right? And we'll call it underscore scripts. And we'll open that up. And we're going to create a C# script called variable practice. All right? Variable practice. Actually, let's call it variable lesson since that is what we're doing here, right? So, and then we're going to open up this file the correct way by going to Assets, open C# project. All right. All right. Open up variable lesson here. And this is our empty C# script file. All right. So let's just type this in. We'll, for the sake of practice, right? So we're gonna pull this here so I can see it, right? And we're just gonna say public put it up here. All right, public int number 1 equals 2, right? So that's a valid declaration of a variable, right? As it shows here, we can, if you wanted to, nobody's going to do it this way. You're never going to see a programmer do it this way. But you can, right? The compiler does not care about how the code looks, right? The syntax it's looking for is the order of the tokens, as they're called, right? So as long as public and int and number 1 are all in the correct order, it doesn't care about that white space, right? Now there are languages that do care about that white space, and if you're programming in them, you need to know that, right? So just be aware of that. Anyway, this looks sane, right? And you should definitely code this way instead of the other way. All right. So moving on. As he says, you don't want to write this way because it looks terrible to read. It's terrible to read, and we want our code to read well so that when we're trying to figure out what's going wrong with it, right, it's easier to figure out. It's easier to debug if your code is clean. All right, understanding component properties in Unity's inspector. Game objects have some components that make them behave in a certain way. For instance, select main camera and look at the inspector panel. All right, let's do that. All right, look at all this stuff that the camera has, right? Each one of these, every time you see a line like this in the inspector, that's another component, right? So components are different pieces that make up the game object, right? So, and there can be any number of components on any game object. All right. When you create a variable, it actually becomes a component property, right? So when we refer to components, we're basically referring to the available functions of a game object, right? The things the game object can do. So, for example, the human body has many functions, such as talking, moving, and observing. Now, if we want that human body to move faster, right? What do? The movement, the function for that would be called movement, right? So in order to make a body move faster, we would need to create a script that has access to the movement component, and then we use that to make the body move faster, right? So game objects also have these components that allow us to do things with the game object, right? You should know that Unity changes variable names slightly when you create them, right? So let's do that right now. So let's take our script and we're gonna stick it on the main camera, right? So variable lesson, put it on the main camera, and then we'll look at the main camera, and you'll see here variable lesson script, right? I don't think I saved it, right? So let's look at that, right? And go back here, and then you'll see number 1, right? As the book says, Unity changes scripts and variable names slightly, right? Note that when you look at it here, number 1 has a space between number and 1, even though our number 1 here does not, right? What Unity's doing is making it more readable in the inspector. What you can't do not put spaces in your variable names. It will break your code, right? Variable names have to be one complete token. They can't have spaces, right? The space breaks the token up, right? So just remember that. All right. So let's just try, let's see, player movement. And we're going to keep public float player movement, right? That, right? And then we'll come in here and look at the inspector. You'll see there's a space and it capitalizes both the words, right? It's the Unity system's smart about that, so it makes it more readable in the inspector, but realize that you can't put space in here. If you put a space in here, you'll get an error, right? As soon as I do that, I will get an error because now it doesn't know what movement is, right? Because it's a separate, it's thinking that you just threw a word in there randomly, right? Don't do that. All right, so next. Changing a property's value in the inspector panel. Right, there are two situations where you can modify a property value: during the play mode and during the development stage, not in the play mode, right? When you're in play mode, this is important, your changes take effect immediately in real time. This is useful when you're trying to test out different values while you're testing your game, right? You should know, though, that anything you do while you're in play mode does not stick, right? So as soon as you stop it, all those changes revert to the way it was before you started playing, right? That's very important, and if you forget that, if you do a lot of work while you're in play mode, you'll lose, and you forget you're in play mode, you'll lose all that, right? So it's very good to know that you are in play mode, because otherwise you will have wasted a lot of time, right? Let's see. The changes you make to the property values in the inspector do not modify your script. The only way your script can be changed is by you editing it in the script editor. The values shown in the inspector panel override any values you might have assigned in your script. If you want to undo the changes you've made in the inspector panel, you can reset the values to the default values assigned in your script. Click on the cog icon, the gear on the far right of the component script, and then select Reset as shown in the following screenshot. So I can come here. So if I say I change that to 5, right? I can come up here and say Reset, and you see it sets back to 2, right? Which is in the script itself. That's very useful to know. All right. Displaying public variables in the inspector panel. You may be wondering what public means, right? As we mentioned before, it means the variable will be visible and accessible. It will be visible as a property in the inspector panel so that you can manipulate the value stored in the variable. The word also means that it can be accessed from other scripts using the dot syntax. In fact, that is what it means in programming in general. Everything's not... C# is a programming language beyond Unity, so you should know that the word really means that it's accessible from other classes, right? From other scripts. That's what public actually means, right? And private means that other scripts cannot access that variable. And private in Unity means also that it won't show up in the inspector. All right. Private variables, not all variables need to be public, right? If there's no need for a variable to be changed in the inspector panel or be accessed from other scripts, it doesn't make sense to clutter the inspector panel with needless properties. In the learning script, perform the following steps. Oh, he called it learning script. If you want to call yours learning script, that's fine. I don't know when he told you to create that, but anyway, so you're going to line 6 to this. All right, so we're going to go and we're going to say take public out and call it private int, right? Save that. Then change line 7. All right. So my line numbers are slightly different, right? Int number 2 equals, I don't know what he had there, 9. Save the file in Unity, select main camera. So we're going to save it. Go to Unity, select the main camera. It's already selected. Note that the number 1 and number 2, what is that? I wish that would go away. I don't know why that's there. Anyway, the number 1 and number 2 are no longer visible in our inspector, right? So that's because this is private. That's explicitly called private, right? You should note that the number 2, we didn't explicitly say it was private, but by default, if you don't make it public, it is by default private. You should know that, right? And it's not that's not the same way. It's not the same thing in all languages, right? Some languages have different rules. It might default to public if you don't explicitly say private, but in C#, you have to make it public explicitly or else it's private. All right. Let's see. And he says it's good coding practice to explicitly state whether it's public or private. That way there's no question about whether it is or not, right? And if you always do that in every language, then you don't have to worry about the language differences, right? Because you explicitly make sure you know whether it's public or private. All right. Naming your variables properly, right? Naming a script or variable is a very important step, right? What you name the variable is up to you, right? You can name it literally just about anything as long as you follow the rules of what you can use in a variable name, right? Like you can't use a space. But as long as you follow the rules, then you can name it anything you want to. But the thing is, you want them to be meaningful, right? If we look at this here, it says public bool or road conditions perfect equals true, right? Public bool or road conditions perfect equals true, right? That is a very detailed and what am I looking for there? It explains exactly what the variable means, right? And what it's used for. But if you, instead of doing that, you said perfect, right? What does that mean? You don't know what that means, right? You might know what it means when you write it, but later on when you come back, you're just like, I don't know what that means. What did I do? Why did I do that? I don't know. So you want to make sure that your variable names express what the variable is and what value it actually holds, right? So you want to be as descriptive, that's the word I was looking for, descriptive as possible, right? And you want them to be long enough to describe what it is, but not too long, right? So there's really no limit to how long it can be. It should be as long as you need it to be, right? There was a time when we didn't, as programmers, want to have long variable names because we didn't have code completion, and typing them, the longer the name was, the more likely you were going to have a typing error and therefore an error in your code. But since code completion works now, we don't have to worry about it. So if I wanted to use player movement down here, right, as soon as I start doing that, I can hit enter and it does the work for me. And you always want to let code completion do as much of the work as possible so you make fewer errors, right? All right, so using meaningful names for variables and methods is helpful not only for you but also for any other game developer who will be reading your code. Whether or not you work in a team, you should always write easy to read code. This is important because you usually, if you go out into the real world, you're probably not going to be working alone. You'll probably be working with other coders, and they will have to read your code, and you'll have to read their code. So you want to make sure that your code is easy to read. All right, next. Beginning of variable names with lowercase. This isn't a rule. This is a convention, right, that you should follow because other coders will follow it as well. But you should begin a variable name with a lowercase letter because it helps distinguish between a class name and a variable name in your code, right? There are some other guides in the C# documentation as well, but we don't need to worry about them at this stage. Component names, class names, begin with an uppercase letter. For example, it's easy to know that transform with uppercase T is a class and transform with a lowercase t is a variable. There are, of course, exceptions to this rule, and every programmer has a preferred way of using lowercase, uppercase, and perhaps an underscore to begin a variable name. In the end, you will have to decide upon a naming convention that you like. If you read the Unity forums, you will notice that there are some heated debates on naming variables. In this book, I will show you my preferred way, but you can use whatever is more comfortable for you. All right. Using multi-word variable names. As we just saw, all road conditions are perfect, right? I'll just copy that, put that here. Right? Note that there are no spaces here, but note that each word after the first one are capitalized, right? And this is called camel casing, right? And you should learn to use that, right? That is the established standard way of using multi-word variable names. All right, next. All right, so declaring a variable and its type, right? Every variable that we want to use in a script must be declared in a statement. What does that mean, right? Before we can use a variable, we have to tell Unity about it first. All right, so I'm going to pause this. I'm going to open up our notes so I can start. All right, so I have opened up my notes document, right? This will be in the notes for this week. We're week 5, but we're working in week 4, right? All right, so from the lesson video, right? So what we're doing here, right? I'm declaring, right, variable, all right, variable declaration, right? Declaration, there we go. All right. There we go. There are only 3 absolute requirements to declare a variable, and they are as follows. We have to specify the data type of data. We have to provide a name for the variable. We have to end the declaration statement with a semicolon, right? So let's put that here, right? What's the dang no, what's going on? It's not going to let me copy that, is it? Oh, there we go. All right. Absolute minimum, right? So let's see that in action, right? So we can say int x semicolon. That is a bare minimum declaration, right? There are other things we can add as well, right? Following the syntax we use to declare a variable. So there we go. Type of data, name of variable, semicolon. That creates that name location in memory that stores data, right? We have told it what type of data we need to store, and then we've given it a name, and that causes the compiler to go into our random access memory and find a place that's empty, and it names that location, and then we have a place where we can put data in there, right? All right. So int number 1 semicolon, that's valid, right? The second requirement of naming variables has already been discussed. The third requirement of ending a statement with semicolon has also been discussed. All right, so we haven't talked about data types yet. The following is what we know about this bare minimum declaration as far as Unity is concerned. There's no public modifier, which means it's private. It won't appear in the inspector and won't be accessible from other scripts. The value stored in number 1 defaults to 0. That's important to know, right? Some languages don't default to anything, right? And if you don't initialize them, you will get an error, right? So, and we'll talk about initialization in a minute. This is hugely important right here. So I'm in fact going to copy that, boom, like that, and I'm going to, oh, you're going to do that to me. Yes, it is. Can I do that? Yes. All right. Awesome. All right. This thing here, memorize this. It's not much to memorize. There's 4 things in there, right? And you need to know them. These are the 4 simple data types, and there's more data types than this. But if you know these 4, you know the basics of what you need to know, right? An integer, int is a simple integer such as the number 3, right? There's no decimal point in integers. They can be negative, positive, so forth. Float is a number with a decimal such as the number 3.14, right? Or negative 2.5, right? There are floats. They have a decimal component to them. A string is characters in double quotes, such as "watch me go now." That's all your character data, right? So any text you have on the screen is string data, right? Numbers can be string data too if they're treated that way. If you don't need to do math with the numbers, right? They become strings, right? And a Boolean is either true or false, and those are very important, and we'll talk about those later. All right. Note, there are a few more built-in types of data that aren't shown in the preceding chart. However, once you understand the most common types, you'll have no problem looking up the other built-in types if you ever need to use them. You can also create your own classes and store their instances in variables. All right, so we know the minimum requirements to declare a variable. However, we can add more information to a declaration to save time in coding. In the learning script, we've already seen some examples of assigning values when the variable is being declared, and now we'll see some more examples. Right. When we create a variable, there are 2 ways to access and edit the values, either by code or by the Unity Inspector panel. Editing the values by code means the values are dynamic. They can be changed at any time. They can be updated at the start of the script or at any other time. If we choose to edit the variables in Unity Inspector panel, we are assuming that the values will remain the same throughout the game. Let's create a new script and test this. All right, so we're going to create a new script. First, I'll save that. Come back here to Unity. There we go. What is it called? It's called a player movement. All right, so we're going to create C# script, player movement. Did he really? I am going to capitalize that because I think he's breaking his own rule if he didn't. All right. Did he? Yes. See, he breaks his own rule right now. He created a class and he starts with the lowercase letter, right? He just told you not to do that, and then he goes and does it, right? So that is awesome. All right. So, but I have done it correctly, so we're going to leave it that way. All right. So player movement, and we're going to add this stuff in here, right? So, let's see. Public int min speed equals 5. Public int max speed equals 10. Public int average speed. All right, he doesn't initialize that. All right. All right, so we have that, and let's see, we've created a few variables, one for minimum speed, max speed, and average speed. The idea is now to calculate the average speed. This means that this value will be dynamic, while the other 2 will be static. So on void update, we'll write a simple line of code to calculate the average speed. All right. So we're going to go to update. I'm not sure why it does it in update, but we're going to do it anyway. All right. Average speed, let code completion do the work for you. So once it pops up there, hit enter, right? And then say equals min speed plus max speed divided by 2. Now we assign the script to the game object camera to test it. All right, so we save that, move over here, back to Unity. We're going to take player movement, put it on main camera. Did that work? No, it did not. And we can also do it this way, right here. Boop. All right, and you'll see min speed, max speed, average speed right there, right? Let's see. We can do this before clicking the play button. By doing this, we are now able to edit the min and max values in Unity. We can do this before clicking the play button or any time after that, but remember that this is only available to do on the Unity program for test purposes. As we can see, the value for the average speed will be 0 until we click play, right? So we're going to click play, and we're going to watch the inspector, right? So we get the average speed of 7. You can come in here and change that, and as soon as you do, right, the average speed changes, right? So just you can play around with that and see how that works. All right. Now, when you stop it, it goes back to the initial values, right? If you change it beforehand, let's say we can do that. Note that the average speed doesn't change right now, but it will change once we start it up, right? All right. And remember, you can reset those values by doing that. All right. Where you declare a variable is important. This is called scope, right? So far, we've learned to create variables, and we've written all of them at the beginning of the script. This is where most of the variables will be written, but it's not the only place we can write. Right? In fact, you can create the variables anywhere you can create class variables anywhere in the class that's not inside a function. But you should always put them at the beginning, because that's what all the programmers I know do that, right? It's because you know that here's the class, right? And right after the class, you put all your class variables. It keeps them all organized, and it makes more sense to me. All right. We will also be creating variables in methods. These variables are called local variables. They are never displayed in Unity's inspector panel, nor can they be accessed by other scripts. This brings us to another concept of programming called variable scope. Variable scope is a fancy way of saying where in the script a variable exists, right? The following screenshot explains the scope of some variables, right? And so if you look at this string block 1, right, there's a block of code which starts with a curly bracket and ends with this curly bracket. So this block 1 is defined throughout the whole class, right? And then the start function starts here, and the define block 2, and it is defined within this block here. And then anything inside of this block is only defined within this block. Right? This takes some experience getting used to it and knowing how scope works, right? As he says, you normally won't create bare blocks of code with curly brackets like he did in code block 3. Code blocks usually include other things such as if statements, looping statements, and methods. This example is just to demonstrate how the scope of a variable works and where a variable exists and is usable. All right, the following is what you have, right? Line 16. The preceding line declares a local string variable block 3. The variable exists in the code block that is labeled code block 3. If you try to use block 3 variable outside code block 3, such as code block 2 or code block 1, Unity will give you an error message saying that block 3 variable doesn't exist. because it doesn't it's out of scope is what we say, right? The preceding line declares a string type member variable named block 1. This variable exists in the code block that is labeled code block 1. So thus the scope of block 1 variable is the code block defined by the curly brackets between lines 5 and 20. All right, so the summary, like I said, I haven't given you an assignment in this video. I'm going to have a separate video that does that. But first, we covered how to write a C# statement, especially the semicolon for terminating a statement. All the component properties shown in the inspector panel are member variables in the components class. Member variables can be shown in the inspector panel or accessed by other scripts when the variable is declared public. The type of data that a variable can store is specified when it's declared. Finally, you learn that the variable scope determines where it is allowed to be used. Now that you've learned about variables, you're ready to learn the details of C# methods that will use the variables we create, which is the topic of the next chapter. All right, so hopefully this made sense. Please email me with any questions you have, and we can do WebEx videos or WebEx meetings or Google Meet if you prefer. Either way, I can help you get through this, right? So look for the other video soon that will detail the actual assignment that I'm looking for. All right, next time.